Exam alert. For the test, you should know that soldering is the preferred method for splicing a cable. This provides the best connectivity and electrical conductivity in a spliced cable. In addition, the join is often as strong as the original wire and provides no additional electrical resistance. For both soldering and crimping, depending on the application, you can protect the finished splice by placing heat-shrink electrical tubing around the splice and heating it to shrink tightly around the cable. Doing so not only protects the splice, but also protects people from accidental electrical shock. Wiring safety. Most wiring and all electrical connections are not intended to be exposed to damp conditions. Even ambient air moisture can provide an arc path for an electric current as it seeks ground. Ground is defined as the natural path that an electrical charge will seek toward the earth, which exists as a conducting body of zero potential voltage. A ground wire is one that connects the electrical component safely to the ground source to keep people from being shocked or otherwise passing electrical charge. If you must install wiring in a moist environment, make sure that you have the proper type of cable for installation in moist environments, NMC, and be sure that it is properly grounded and that no connections are exposed. You will ensure proper grounding either by connecting the ground wire, bare or green, to a green screw on the fixture outlet box, or by splicing it to the ground wire in the source wiring, for instance, if you are extending an electrical circuit. The most important thing to remember when you are dealing with electrical wires is that you should never handle wires without first interrupting the electricity in that particular circuit. Failure to do so may result in shock or electrocution, because the electricity will use your body as a natural ground path. Caution. If you are experiencing electrical problems, such as smoke, arcing, blowing fuses, or tripping circuit breakers, you should interrupt the electrical supply to that circuit until you can locate the problem. You might have a damaged electrical cable or faulty equipment, or you might be overloading the circuit. Also, if you are having problems with a breaker tripping often, you most likely have either a load larger than the circuit can handle or a short circuit. A short circuit is an indicator of abnormally low resistance in an electrical circuit. It can potentially cause circuit damage, overheating, fire, or explosion. Coaxial cable. Coaxial cable, often called simply coax, is an electrical cable with an inner conductor surrounded by a tubular insulating layer. The insulating layer is usually a flexible material with a high dielectric constant that is then surrounded by a conductive layer that is either fine, woven wire, for flexibility, or a thin metallic foil. The entire structure is then covered with a thin insulating layer on the outside. If the core is stranded, the cable is more flexible than a solid core cable. Coax is not for providing electrical service, but is used for transmitting radio frequency, RF, signals. Applications for coax include connecting radio transmitters or receivers to an antenna, making computer network connections, and distributing cable television signals. The electromagnetic field that carries the signal resides in the space between the inner and outer conductors. Because of this, coax cable can be installed next to metal objects without power loss, and the signal is protected from external interference. Resistors. A resistor is a component that offers more resistance to the flow of current than an ordinary. Can limit the current or adjust the voltage in a circuit. By choosing the proper value of resistor, you can precisely control the value of the current flowing through a circuit. You normally find two types of fixed resistors in electrical work: carbon composite and wire wound. A fixed resistor always has the same degree of resistance, but some wire wound resistors, called tapped resistors, have an adjustable sliding tap that lets you choose a certain value of resistance. In addition, some wire wound resistors have fixed taps that provide fixed values of resistance between their taps. These are called variable resistors. Potentiometers and rheostats are two types of variable resistors. Figure 6.15 illustrates the schematic symbols for fixed, tapped, and variable resistors. Resistor. Tapped resistor. Variable resistor. Figure 6.15 schematic symbols for resistors. When current flows through a resistance, it produces heat. For that reason, Appliances such as heaters and dryers often use wire-wound resistors to dissipate some of the heat the appliance generates, keeping in mind that any heating element is basically a controlled short circuit for the purpose of generating heat. Without the resistor, the electrical circuits might overheat and cause damage to other components on the circuit, or even start a fire. However, in many other applications, heat is not a desired effect, and a resistor that gets too hot could destroy itself or cause fire or damage to the equipment. Because of that hazard, manufacturers must ensure that devices have the correct value of resistor to moderate that heat. Transistors. A transistor is an electronic component that performs certain electrical functions, such as regulating current or voltage, and acts as a switch or gate for electronic signals. A transistor consists of 3 layers of semiconducting material, such as germanium or silicon, each capable of carrying a current. Refer to the previous discussion about semiconductors. Figure 6.16 shows the schematic symbol for a transistor. Figure 6.16 schematic symbols for transistors. Capacitors and capacitive reactance. A capacitor is a passive device in an electrical circuit that stores an electric charge. The simplest capacitor consists of 2 parallel plates, one positive and one negative, of conducting material with non-conducting material, a dielectric, between them. The dielectric can be of a non-conductive material, or even air. The most common types of capacitors are fixed and variable. Figure 6.17 shows the schematic symbol for a capacitor. Figure 6.17 schematic symbol for a capacitor. As electrons leave the negative terminal of the power source, they move on to the capacitor's negative plate. Because the dielectric between the plates will not allow the electrons to travel freely from one plate to the other. The electrons begin accumulating on the negative capacitor plate until the stored voltage in the capacitor equals the line voltage from the power source. At that point, the voltage is sufficient to force the electrons from the negative plate, through the dielectric, onto the positive plate of the capacitor, and back into the circuit. This process is called charging the capacitor. In your everyday life, you have experience with this phenomenon. Every time you turn on your television, you experience a slight delay between the time you press the power button and the time you see a picture on the screen. That's because your television has a capacitor in its circuit that it must charge.